Hello. As I mentioned in my last short video that I will be talking about the new scanner from Siemens that you can communicate with Ethernet IP without the need of a Profinet. So this is it. So here they call it the LCCF Internet or Ethernet Scanner block. So this is a block that will do the magic. So when we will talk about this, there will be a lot of documents that you can use to make this easy job for you. And I will start mentioning the Siemens documents that will explain that to you, which is first the Ethernet IP scanner, connecting third-party IOs using Ethernet IP. What I did, I connected my Fanuc Robot to my 1214 CPU Siemens to talk to each other without any third party, without any Profinet communication. The robot I have has adapter Ethernet, and the Siemens is just a normal the 1214 CPU Siemens using the same board on the CPU, the Ethernet board, the Profinet board. So this is documents that you want to go first to download the document that explains the step-by-step example if you want, and the library that you will need to get the job done. So as we see here, works only for the 1200 and the 1500 BLC, Siemens BLC. It's not going to work with the 300 or 400. And also we see here the versions. I guess the earliest one you can go with is 15.1. Here I'm using the version 16, so I did download version 16, and I did download the documents. And now here's the document, not this one. Here's the documents that's gonna guide me step by step to how to do this messaging between the Ethernet IB device and the Siemens BLC. So we know there's like a master and slaves, and there is in Ethernet IB word there's a scanner and adapter. So the Siemens usually it's a master, like going with the Profinet and stuff like that. But now it's going to be as a scanner to talk to the adapters on the Ethernet IB word. So my robot will be adapter Ethernet, and the BLC will be the scanner Ethernet. So let's start here in the Siemens. So after you download that library I showed you, you're gonna have to come here to the libraries, and you want to add it to yours. Mine is right here already, but you go here, you look for it, whatever you had it, and it's gonna be compressed, so you have to choose compressed, and then you will find it. After you added it, it comes here. You open it, there's a few things that you will need from it. First, you choose which PLC. Mine was 1200. And these two that you will need to add them to your tree. So this function, you're gonna have to bring it, just drag it to your PLC where you want to add it under your program blocks. You add it here. I added right there. This is where I dragged it. I just created the new folders and I dragged it inside it. I named my folder Robot Scanner to contain all the data in the same place. And then also you will need to bring the data types. So these three, you will need those three also here. So those are these data types right here. These three data types, you can just drag the folder and you bring it above the existing data type. It's gonna generate these three folders for you. So when you do that, now you are ready to start. First thing you want to do is create a scanner. You name it whatever you want, but you need to create a cyclic interrupt. For example, I'm gonna create one just to show here. So I'm gonna go add new OB cyclic interrupt. and then you put the cycle time you want. I put it 10 millisecond, but you put it whatever how cycle time you want it, how fast you want this cyclic to interrupt the cycle, and you name it and language, and then you okay. Here you go. This is my cycle interrupt. Now when I have this, I will drag the LCCF function block to it, and by default it's gonna ask you for instant DB to go with this function block, and you name it whatever you want, you number it if you want, and then you create it. And now you have these two, which is mine is right here. This is the instant DB, and this is my function block. Now it opens like this. So you're gonna start fill all these data. To do that, you will need, let's go back to mine and show you what I did. So for enable, I just enabled it all the time. You want to enable it with the anything you want, with the e-stop signal, whatever, but I have it true always. For interface is the interface that you want to use to communicate with this adapter. So mine is I'm using, let me go show you. I'm using only one board. I have only one interface on my CPU. So that's what I'm going to be using. So if I go to the device configuration, I would go to properties for this PLC, and then I go to system constant. I will see the interface for my PLC, the Profinet interface, which is this board. And that number, the hardware identifier is 64. So my board number is 64, and that's what, go back to my here, close these now. That's where 64 came from, is the interface board. All right, continuing, adapters and data. These are coming from the data type that we added. This is the adapter configuration, and this is the adapter data. So the adapter is going to go here, then the data is going to go here. But you're not going to just move it. You cannot just move it. So what you're going to do is you're going to create a new DB, which is I created this DB right here. I open it, and in this DB I added two new tags, and here I defined them as arrays, and the type of the arrays is these two that I need. So I created adapter. I made an array of 2 elements. All you need, if you have one robot, like for my example, I'm communicating with only one robot, so all I need is one element. But I followed the example, so they had it something like that. So I'll be working with element number 0, number 1 will be spare. But this array, the most important is the type of the array, that's the data type that I brought here. So the first one is the adapter configuration, and the second one is the adapter data. So if we open these to look at them a little bit, the adapters is going to have, here we go, I'm using just element 0, is going to have all the the IP address, is going to have the IP address for the device that I'm trying to communicate with. Like in my example, the robot is going to have some data of the robot also to find it on the network, because it's going to have, the network is going to have tons of stuff, so I need to identify which device I'm trying to communicate with the IP address, and also what language I need to talk to this, what language I need to talk to it, this is what all the rest of the data, and we will go through it and we will see how to get all this data. The second one is the EIP data is number 0, for example, is going to be the inputs and outputs. Here where the inputs and outputs is going to go. So what you can do is minimize this, get it out here, and you can just here drag the adapter here, and it drag also the data here, and that's how you're gonna have it. Now you have them here. So let's go get this back here. All right. So that's for adapter and for the data. The other side, these output sides, just internal tags that you will create just to status for the communication, just to let you know if it worked, if it didn't work, if it's busy, if it's active, status signals. You create your internal tags to just monitor this block. This is the main important block. Now, filling the data in our DB. Find the data that needs to go here, and how to organize the inputs and outputs. To do that, we'll have to have all the information about your robot. So for what I did, I contacted Fanuc. I asked them for the GSD file for the controller that I have, and they sent me the GSD file, which is right here. This is the GSD file, and when I open it using the notepad, I can see all the data that my PLC asking me about. So for example, the PLC asking for one of the data is the product ID, the vendor ID, the product ID, the product code. So all those I can find them in the GSD file. For example, right here, the vendor code, right here, the product type and code. So all these information I can find them here, and there's more information down here, but it's gonna get like a little bit too much when you have so many boards in your robot, for example, and obviously this controller that it works with many different robots, so that has a lot of options. So there's an easier way, which is if you ask Fanuc for this manual for the controller that you have, which is in my case R30IB Plus, Ethernet IB setup and operation manual. If you get this manual, you will get all this information you need in one table or two tables, because there's a small table here that we need more data, but here, right here, gathered for you is not shredded, and you don't have to look for it. So this is the data that you will need to set up your communication. So let's start here. Let's open here, make this smaller, for example. So let me make it easier, and let me open my interrupt again. And what I did, the only thing that I really need, I put them in the networks. So the first network, I will need to move the IP address to the adapter 0 address, and 1, 2, 3, and 4, and that's your robot IP address. So I put 192.168.0.6. That's my IP address, and I put it in a separate network, robot IP address. The other thing you need is the vendor and the product data. So here we start the fun, which is if you have the manual, still clear. The 356 is the vendor ID. It goes in the vendor identifier. I will come to 3 here. Hold on. And 12 for the product type and 4 for product code. 4 is right here, 12 right here. And here in the manual it shows you 4 or 40. 4 or 40 or 12 or 140. And I believe 40 and 140 is if you have a safety through Ethernet. In my case, I have no safety through the Ethernet, so mine is 412. And if you have the GSD file, it proved my point that I am 12 right here, 4 and 12. I'm not the 40, 140, and that's because the safety over Ethernet, which I don't have. So right here, that's what 356, 12, 4 came from. Revision for 3 and 1, the revision major and revision minor are in the second table right here. For the 12 and 4, which in my case, my revision, the major and minor are 3 and 1. And that's what my major 3 and 1. So this is for the vendor and the product data. If you do it like that, and you move them to the adapter 0 vendor identifier, all of them, they go here. The vendor identifier, product type, product code, revision major, revision minor. Those are the one we filled so far. Now we will continue with the rest. Need this anymore. So we will continue. We'll go down. So here now the input and output data. The input and output data. So the first thing is the assembly instant, which is also, it's in the manual, all of it in the manual. Configuration instant, which is the assembly instant. Let me move it here. It's 100. And the configuration size is 0. And the configuration size is 0. So the 100 and 0 for the configuration instant and configuration size, it goes under assembly instant and configuration data size. For now, output identifier and output size and input identifier and input size. So the size is how many bytes you want to move. In my case, I'm moving 32 bytes input and output between the robot and the PLC. So 32 bytes I'm moving. And the identifier is coming from here. Make this a little bit bigger. So here shows you the input instant is 101 if you're using slot 1. And it goes on until 132 if you're using slot 32. And for output, the same thing. It's 151 for slot 1. And it goes on until 182 to slot 32. And also there's more slots if you have more slots. So my case is, I'm slot 1. In the Ethernet I'm using is rack 89 slot 1. So in my case is input is 101 and output 151. And here is the size, the input size, user configurable, set in 16-bit words, minus 32. This is we will talk about this because the robot it talks words, but the PLC talks bytes. So in the PLC we have 32 bytes. That's what we're moving, and the output 151 and the input 101. That's where that came from. So one more time here, the data for moving the inputs and outputs. And the last thing is the cycle time for this. Cycle time. I have it 20 milliseconds. You can go less, longer, whatever you see, how fast you want it. And that's it. That's really all the configuration that you need to do in a PLC to make the communication works. In the robot side, now, if we go to robot side, you will do it normal as you're doing any Ethernet IPs. For example, you're going to go to menu, you're going to go to the Ethernet, you're going to configure the connection number 1, and here it shows that nothing configured. So you change this to, if like in my example, 32 bytes, but here by words, so it's going to be 16 words. So I put 16 here if I want to, and then if the whole, after you finish and you run this connections and you have all the data set up, when you come back to this screen, you should see here the IP address, and you should see here the transfer, like it's going to be looking like this. This screen should look like this, showing you that I am communicating with the PLC IP address. This is a PLC IP address, and this is transmissions. Okay, so this is this screen. The other thing you need to configure in the robot side is the IOs, the UART, and the digital. For the digital, you just do it. This is not my example, but my example here. Right here, the inputs and outputs. Come here. Just normal Ethernet, 89 rack 89 slot 1 for inputs, output the same rack 89 slot 1, and the start, whenever you want to start from, I start from here 21. I didn't care about 21 and 19, but it added it by itself. But you start from anywhere you want, and the UAP. You're gonna have to configure that too. Now, I will come back to this because there is a couple of things you need to pay attention whenever you use this scanner, and I will go through them after I finish explaining this scanner. So after you do all this configuration, you should be set to have your PLC talking with the robot. The downside, which is that's what I'm going to be talking about, UAB, but I will come back to it in a second. The downside here is this scanner, it takes a little bit, a lot from your CPU. So if I want to go to program info, this memory I have 67 used right now. Probably at around 40% it was because the scanner. So between 35 to 40% from this usage was just for the scanner. So if you have the small PLC and you have a huge project, maybe you need to consider make the math before you start doing this. But if you have a like small project, in my case, I'm using 1214, which is small memory. But my project is one robot and few other devices that I'm communicating with. So I'm using only 6. I've finished my project with just 67 usage. So I still have a lot to use too. And if you're using the 1500 PLC, they come with a huge memory. You don't have to worry about it. Really, like was not an issue for me, but I need you to make sure that this scanner will take space from your PLC. The other thing is the PLC was so happy with this communication. I never had issue with the PLC side of it. The robot side of it, though, it looks like the robot was a little bit faster than the PLC. So the robot sometimes it thinks the PLC is not updated itself with this scanner. So it was giving me some messages that, let me open here. Yeah, it was giving me sometime that this signal, the IMSTB, dropped, and it's not good for this to happen. If this drops, the robot will stop, and you have to reset it and start it again to go on. So you don't want that. So the 4 signal that everybody knows that needs to be on for the robot to run are these: the IMSTB under the UI, the IMSTB and the hold and the SFSBD and the enable. Those 4 signals, they have to be on all the time for the robot to keep going, right? So since I have sometime, like really once every hour or 2 sometimes, it used to drop. So what I did, I configured them different. These 4 signal, because I want them to be on all the time. The way I configured them, let me try right here. I configured them as a flags. 34 is a flags. Where's that? Right here, 34 flag marker. This is the rags. I just googled it. Fanuc rags. 34 is the flag markers. So how I use this? I used it. So the first 3, because as you saw, they have space between them. Why I cannot? Here. The first 3 and number 8. So what I did, the first 34, start from flag 1 to 3, and number 8, rack 34 again, and flag number 4. The rest, I kept them 89, which is the Ethernet, because they not, it's not like very important, the cycle, like the time when they come. So start, for example, even if there was like a few, even if it was 1-2 millisecond delay, it's fine. When the robot get the start, then starts. So, but those 4 I had to do this. So what I did, I put them in a flag, and I came here, which is I named it data, but it's a program inside the Fanuc Robot that in the background, running in the background. And I told him that these three signals that I don't want to control the robot with, I don't want to use them. So like I told them to stay on all the time. But the hold signal, I want to control it from the PLC. So I told it this signal, if I want to control it, for example, for the door open. Whenever they open the door, I want to put the robot on hold. And then after that, allow me to go to inside the cell. And when you open the cell, that's it. The robot is not going to go anywhere because it's a safety fence open. Say like wires will be stopping the robot. So the e-stop and the fence signal are hardwired. So when you open the fence, that's it. The robot is not going to go anywhere. But to give you to allow you to go open the fence, I need to stop the robot first, and that's how I did it. So there's a signal DI coming from the PLC. When I press that one, request to enter, for example, whenever the robot receives that signal, it's gonna drop the flag for number 2, which is the hold signal. It's gonna turn it off. The robot will stop, and when the robot stops, the door will allow you to go in. And then when the signal goes away, the request to enter is not on anymore, turn hold signal on again. So, and that works with me perfect. So this is the other thing that I had to do. So in your application, if your application is so sensitive, cycle time sensitive, and you cannot waste like 2-3 milliseconds sometimes every hour or two, then you have an issue. But I don't see any application that you cannot waste 2-3 milliseconds every couple hours. So on my side, like it's been working for months now, and no issues with this communication. For the UO, you can keep them 80. You can keep them 89 because those are going, and they are not really like these signals, just a feedback. In your PLC, you can control it. In case there is something that you're really monitoring, you can take care of that. That's that. The other thing, when I want to mention that is when I was setting up this robot. Let's go to menu. Oh no. Menu, next, system configuration. Here I have this true, but I had this false. I have to have this false unless you want to use UI 18. But if you're not using UI 18, which is I'm not, this has to be false, so you can control it from the PLC, start it from the PLC. So under the system config, start for continuous, only have it false for it to work. And for sure you have to do the other ones, which is, you know, the other, you have to put it in remote and all that stuff, the important stuff for Ethernet, but this is another important one, has to be false. That's all the robot side really that I had to do. In the PLC side, I had to add a couple of things, which is, let me show you here. As we mentioned, the input and outputs, when they come to the PLC, if you remember right here under the EIP data, the downside here, they come as unsigned integer. They don't come bit by bit, where you can name them whatever you want and use them separately. They come in as integer. What I did to go around that is I created another DB. I will open it here. I created this DB, and I have this robot signaled, and I created one for input, one for output, and I named all the tags. I put them down as they are in the robot. Here the inputs, all the inputs, and if it's a spare, I kept it DI number. But if I'm using it, I put it as the name that what I want it for. For example, right here, this is coming from the input. So if we go into the robot, we see the first under the UI, the first one is command enabled, system ready, program running, all those. I list all those. And then also in the DO, all this DO 1, 2, 3, 4. So those are as an input to the PLC. So I put them separate one by one here. And then in the FC, I use the book block to move the data from that DB, the DB for the scanner, this DB that has the integer, to the new DB that I created that has each bit separate. And the way I did it, right here, we can see the book block. You can type it in and put help. It will explain everything to you how to use this block. Let me see if it's 84. If you go to the help, it will show you 84 is for the DB. So you're moving data from a DB. The DB number is 2, which is this is a DB2. Start from 56, which is right here. Start from 56. And move all this data to another DB. 84 is it, another DB. Number 1000. Start from 0. Start from byte 0. And how many bytes? 32 bytes. I'm moving 32 bytes. And this, how you move the data from the DB that's for the scanner to another DB that you can configure it as you like. And I thought about, yes, okay. And that was helpful for me to separate them and look at them separately. And here I have them, and I move them and I name them whatever I want. Acknowledge, robot out of the area, and all that stuff. All right, so that's really all you have to do to get this communication running. And let me make sure if there's anything else here. You have to run this connection when you finish, so you can see this IP address and communication. If it's happy, UI. Okay, this done. I think that's it. And if there is any question you guys have, you can ask me and I will go in more details if there is something I missed, or if you have any more need more details. But it's been working for me, and it was very nice to get it working when I needed Profinet module for my robot, but Fanuc they didn't have it, and I ordered it in May. Until now, I don't have it yet. And last time I heard is gonna come in January. They will have it available in January. So like I have this done, and the robot is working for months right now, so it's perfect. Well, thank you very much, and don't forget to ask more questions if you need more details. Thank you very much.